Hello everyone. Okay, so in this video we are looking at the derivative of trig inverse function. So we were looking at the derivative of trig functions last video. This video now we're looking at inverse. So again, these are all in our log tables. So cosine inverse of, and it's in the form, here are angles in the form x over a. X over a, that's the first derivative is minus 1 over square root a squared minus x squared. And sine inverse x over a is 1 over square root a squared minus x squared. And then tan inverse x a over a squared. So like all of our ones before this does the chain rule. So again, so cosine say inverse of 3x plus 1, right? So remember, this is my outer function. This is my inner function u. So remember, to find dy dx, I find the derivative of my outer function, with respect to u, multiply it by the derivative of my inner function, du dx. And that will give me my full derivative here. So all we need to remember is we need to multiply by the derivative of my angle. So let's look here. So how we do these ones is we need to identify what my numerator is, what my denominator is. And then we always end up just multiplying by what my numerator, multiply by the derivative of my numerator, and that will usually give us our inverse. So let's have a look here. Tan inverse of 2x over 5. So the x, I'm putting quotation marks, of my formula up here is going to be equal to 2x, and then the a is going to be 5. So the derivative of x is going to be equal to 2. Okay, so that's good information. Let's put it in. That is going to be equal to a 5 over 5 squared plus x squared. And then I have to multiply by the derivative of my numerator, which is 2. So my final answer is 10 over 25 plus x. And that is the derivative of tan inverse 2x over 5. Let's try it with cosine inverse. So I'm going to rewrite this one. Right, as you see here, it's not giving a fraction at the minute, so we need to rewrite it. So I'm going to rewrite this as cosine inverse x cubed plus 3 all over 1. The same thing, right? So my numerator, the x in my formula, is this going to be my numerator, which is x cubed, and my a is going to be equal to 1. So my derivative here of x is going to be equal to 3x squared, and 3 goes to 0. Then let's sub it in. So my derivative, dy dx, is equal to minus 1 over the square root of a squared minus x squared. So a squared is 1 squared, which is 1, minus x squared. X cubed squared. And multiply by the derivative squared. That will give me minus 3x squared all over square root 1 minus x squared. And that is my derivative there. So let's have a look at some questions here. It's some 2012. Differentiate sine inverse 2x with respect. Well, my x in my formula, my numerator is going to be 2x. My denominator is going to be 3. My little derivative here is going to be 2. So the answer is going to be 1 over square root of 3 squared minus 2 squared. Derivative of the angle, which is 1 over root 9 minus 4x squared times 2. Put the 2 on top here. That's 2 over square root of 9 minus 4x squared. Easy peasy, lemon easy. Next one, 2005, sine inverse x over 5. Well, x is going to be equal to x a to 5. The derivative here is equal to 1. So it is going to be equal to 1 over square root of a squared, 5 squared, which is 25, minus x squared, multiplied by derivative, which is 1. But that's my final answer right there. Stunning. This one here. This one's a bit more tricky now. It's from 2013. Y equals x plus sine inverse x. Prove that 1 minus x squared times the second derivative minus x times the first derivative plus x equals 0. So let's find the first derivative here. So this is going to be dy dx is going to be equal to 1 plus sine inverse x over 1. Well, that's going to be x. So it is going to be equal to 1 over square root of 1 squared, which is 1, minus x squared multiplied by the derivative of x, which is 1. So that is my first derivative there. Let's ask me now here to find my second derivative because I need it for this part. So my second derivative is going to be equal to 0 plus, I'm going to rewrite this as 1 minus x squared to the power of minus a half. So rewriting this whole term here. So it is going to be equal to 0, 1 goes to 0, plus, now chain rule, minus a half times 1 minus x squared minus 1 minus 3 multiplied by the derivative of this in here minus x. Second derivative is going to be equal to a half minus a half times minus 2x is going to be equal to x times, well, that is all going to go under here as 1 minus x squared times root 1 minus x, right? Because this is 1 to the half the altogether. Okay, that's my second derivative. Fine, let's now solve this. So 1 minus x squared. That's my second derivative, which is x over 1 minus x squared times root 1 minus x squared minus x times my first derivative. My first derivative, 1 plus 1 over root 1 minus x squared plus x equals 0. So let's simplify this. This 1 minus x squared will cancel here the numerator, so that's why I did that earlier. So I'm going to have x over root 1 minus x squared minus x minus x over root 1 minus x squared plus x equals 0. And we're lucky here, these all cancel out. Minus x cancels out with plus x, and then plus x over root 1 minus x squared minus x root minus 1 minus x squared can be equal to 0. 0 is equal to 0. QED proven true. What a fun question. Right. And finally, this last two parts here is from 2000. Y is equal to sine inverse 2x minus 1. Find dy dx. Calculate its value at x a half. So that's going to be, so my x is equal to 2x minus 1. My a is going to be equal to 1. Right, because all over there. So my derivative here is going to be equal to 2. Subbing it in, it's going to be 1 over square root of 1 minus 2x minus 1 squared divided by 2. That is going to be equal to 2 over root root 1 minus this squared out is going to be 4x squared plus minus 4x. We multiply this bracket, it'd be minus x 1. Now that's just going to be 2 square root of 1 minus 1. They're going to cancel there. It's going to be 4x squared. Any other work I could do on this one? I don't think I need to go any further, but I'm just feeling easy. 2 over. I could factor out a root 4 here from each. Root 4 times root x minus x. Well, root 4 is equal to 2. And 2 divides into 2. Okay, so I'm left with 1 over root x minus x squared. Stunning. Now I just need to evaluate x equals to a half. 1 over root a half minus a half squared. All that in the calculator. 1 over root. And look at that. Equal to. What a lovely question. Right, and then the last one I'm going to be doing is from 1974. Right? So sine inverse of cosine x. So, again, so write this over 1. So my x in my big formula up here is going to be equal to cosine x. My a is equal to 1. My derivative of cosine x is just sine x. So, dubbing it into my formula, it's 1 over root 1 squared minus cosine squared applied. What's I derivative is minus sine. I do apologize. Minus sine x. So I have minus sine x over root 1 minus cosine squared x. Oh, this question is going to be fun because I realize that this here we call 1 equals sine squared plus cosine squared. So 1 minus cosine squared is equal to sine squared. So I can replace all of this in here with sine squared x. So I have minus sine x over square root of sine x. Well, that's just going to be sine x. I'm cancelling out the square of the square root. Minus sine x divided by sine x is just going to be equal to minus 1. How fun is that question? Anyway, they were just the trig inverses. I hope this kind of helped you, and see you guys later. Bye.